In this Back to Basics video, we'll be looking at the fundamentals of grade 10 and 11 waves. In the beginning of the waves, we looked at the concept of a transverse pulse. Remember that a pulse is a single disturbance which moves through a medium. So if we look at the diagram we have, the single disturbance starts when we move the medium once and it returns to its original place. The energy moves away from the point where we disturbed it and we see the pulse moving. If we disturb the particles at a right angle or perpendicular to the direction of movement, we call that a transverse pulse. Most people instinctively think of C waves when they think of transverse pulses, and they would be correct. Notice that the wave is not actually an object. It is simply a movement of particles up and down while the wave moves at right angle to their motion. We need to measure how much energy is in a wave, and the first thing to look at is the wave's amplitude. This is defined as the maximum displacement of a particle from its rest position. So if we look at our original pulse over here, our rest position is this part, where particles are furthest from their resting position. However, the amplitude is not always enough. We actually need to know how long this pulse is that gets us pulse length. This depends on many factors, but is always measured from the first displaced particle to the last. Amplitude position to the maximum displacement, pulse length from the beginning to end. Transverse pulse because it's perpendicular, the movement of particles are perpendicular to the direction of motion, and it's a singular pulse because it's a single disturbance. So if you look at the diagram, we have a hand that's moving a string up and down. The particles you can see by this arrow is moving up and down all the time, but the energy of the wave is moving towards the wall. This is what waves do. They move energy away from the disturbance to another place. For a complete wave to happen, the particles need to return to their original position and be moving in their original position. This is called a complete cycle. Just like the seasons, from spring through summer, through autumn, winter, and back to spring would be one cycle. A period is defined as the time it takes to complete one cycle. As with most measures of time in physics, we measure this in seconds. Closely related to period is frequency. If something is frequent, it happens often. So when we describe the frequency of a wave, we define it as the number of times that the wave completed a cycle in a second. It has a unit known as Hertz, or Hz for short. So, knowing how a transverse wave works and how it's produced isn't enough. We actually have to know the parts of the wave because they are important in other sections of the waves. Most of our descriptions will be about mechanical waves. That means that the waves move through a substance. This substance is called the medium. The rest position is the place where particles in the medium would be if we left them undisturbed. When we disturb the medium, the wave being produced, we create high points known as crests and low points known as troughs. A crest is the maximum positive displacement from the rest position. The trough is the opposite. It's the maximum negative displacement from the rest position. The crest is like the position of a water wave in the sea. The trough looks like a feeding trough. It looks like a bowl so we can put something in there, just like a trough that animals might eat from. We also have amplitude. Amplitude is the maximum displacement from the rest position. It's either to a crest or it can be to a trough. The wavelength is the same as the pulse length, and we define it as being the distance between 2 points in a phase. It's the length of a single cycle. They both go up together and will both come down together. Definitions are very important, so remember. Amplitude is the maximum displacement of a particle from its position of rest. Crest is the highest point of a wave where there is maximum displacement from position of rest. Trough is the lowest point of a wave where there is maximum displacement from its position of rest. Points in phase are points in the medium which have exactly the same movement at the same time and are equal distances from the equilibrium position. Points out of phases are points in the medium which do not have exactly the same movement at the same time and are not necessarily equal distances from the equilibrium position. Wavelength is the distance between two consecutive points in phase. You must know, it's also worth noting that frequency, speed, and wavelength are related mathematically. The next Back to Basics will look at that mathematical relationship.